Assalamualaikum and hi everyone. My name is FATIHAH binti ANUAR from S1 K3 P3. So today I would like to teach you guys about chapter 7 permutation, which is subtopic 7.1. So what is permutation? Permutation is a mathematical technique that determines the number of possible arrangements in a set when the order of the arrangement matter. So now we move on to the formula permutation. So formula for permutation is n factorial over n minus r factorial. So n is referred to the total of objects in the set, while r is the number of choosing objects from the set.
5 children are to be seated on a bench. Find how many ways the children can be seated. Since this question doesn't need to apply any restriction, we can simply calculate 5 factorial equal to 120 ways the children can be seated. Next question. How many arrangements are possible if the youngest child is to sit at the left-hand end of the bench? Since the question says the youngest child need to sit at the left-hand end of the bench, so here is 1 factorial and another 4 children left is 4 factorial. So we multiply and we get 24 ways.
7.1 Permutations. Find the number of arrangements of letters in word algebra. In how many of these arrangements A. The two A's are together, B. The two A's are separated, C. Start and finish with an A, D. The vowels are together. The question asks for when the two A's are together. In words algebra, there are 7 words, so n equal to 7, and there's 2a. We put it together at the front, and the others at the back, which is L, G, E, B, and R. So we count A and A as 1, and the other words as 2, 3, 4, 5, and 6. So therefore the solution is 2 factorial over 2 factorial, because there's 2a, multiplied by 6 factorial, which is equal to 720. B. The two A's are separated. So we separate all of the alphabet, because there's possibilities of putting an A behind the alphabet. So there's 6 places, so 6b2 divided by 2 factorial, because there's 2a, and we multiply by 5 factorial because L, G, E, B, and R. So the answer is 1800. Start and finish with an A. So from algebra, there are 7 words. So we put 7 places and we put A at the start and A at the finish. So there's 5 places in the middle. So 1, P1, multiply by 5 factorial and multiply by 1p1, which is equal to 120. D. The vowels are together. So we put all the vowels at the front together, which is A, E, and A, and we count it as 1. Then we put L, G, B, and R. So we count A, E, A as 1, L as 2, G as 3, B as 4, and R as 5. So 3 factorial because A, E, A, there's 3, over 2 factorial because there's 2A, which is the same, and we multiply by 5 factorial. So the answer is 360.
Moving on to the use of permutation in real life. The first one is to determine the number of sequence of letters and number. For example, a father who was waiting for his wife is in labor. He was prepared A and I name for the baby that will be born. Moment later, the midwife told that she will give birth to the twin. The father thought how many twins can be named using the letter in the word A and I. From this story, the old man took the first letter of the three available letters. Next, take a letter to the second letter of the two remaining letters. Finally, take a single letter for the rest of the third letter. If we find the number of letter A and I to the another name by the manual can be A and I and AIN, IAN, NIA, NAI. Based on the basic rules of counting, the number of arrangement three elements differ in no particular order with no element that can be repeated is 3 times 2 times 1, which is get 6 arrangement. In general, the preparation of n distinct element in a specific order with no repeated element is called a permutation of n element. One is to determine the arrangement of color on the flag. As we know, the color of Indonesian flag is a red and white. Whereas if the position of both colors, red and white, is altered, then the meaning of the different color and the flag will be turned into the Polandia flag. That's thing that seems trivial permutation proof using concepts that are applied in a daily life.
This is NAZATUL ANISHA binti AZHAR, and I'm going to explain about application of permutation. So, permutation is an arrangement of those objects into a particular order. So, there are many examples in real life, but I choose a few examples to explain detailing. So, the first one is digital locks, and the second one is car race, the third one is choosing clothes, and the fourth one is painting. So firstly, digital locks. Digital locks, a combination lock should really be called as a permutation lock. Permutation lock has 3 inputs. If the order of input changes, it won't unlock, even though the numbers are same, but order plays its role. So that's the useful of permutation in digital locks. So the second one is car race. There are 8 cars in a race, and the goal was to predict the correct finishing order of all 8 cars. This is a permutation problem because order matters. So the answer is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 and equals to 40,320. So the probability of picking the correct order will be very small indeed. So the third one is choosing clothes. If you have 3 shirts and 2 pants, using all those you can create maximum number of pairs of shirt and pants. So for example, you have 15 shirts and 10 shirts. You can make 150 pairs of shirts and pants. So that's the permutation. So lastly, we will go for the paintings. So you want to paint your room. Your room has 4 walls and you have 3 paint colors. Each wall can be painted 3 different colors, but you have 4 sides because the room have a 4 walls, right? So they have 4 sides. So you can paint it in 4 times 3 times 2 and times 1 equals to 24. 24 different ways. So that's all for me. Thank you.